Induction versus deduction. Let's go over the basics. Now, induction is a cognitive process of forming a generalization. Deduction is a cognitive process of applying a generalization, basically. So, this forms generalizations, this applies them. Forming, applying. So this is parasitic on this. Without generalizations, we cannot apply them. Very important. We need that in life, but we got to do this first. We got to find out what things are like. Then we can apply this henceforth in life, as long as we remember. Induction. For example, all humans are mortal. We form this general idea. Forgot my R. Mortal, not motal. All humans are mortal. So we get a bunch of particular things, and we can form this generalization about all of them and be certain about it. I'll just call it a gen for short, generalization. I'll write it out this time. But in deduction, I like to take a classic deduction, for example. It comes in a little packet instead of this, which summarizes a bunch of evidence and information and reasoning. This encapsulates some thinking and study we did about all things of a certain kind. Deduction will say all humans are mortal. I just abbreviate it like that. Socrates is human. Therefore, Socrates is mortal. There is a deduction, a classic. We get this general idea, we apply to this particular, and see that Socrates is mortal. So, we can't do this without having done this first. This, as I say, is parasitic on that. For this to exist, we must have formed it. If it's going to be any meaningful, be meaningful. It's not empty. We got a content to that and know what we're talking about in the world. Otherwise, we start to have failures on that. But this, we see we're getting a generalization, and we apply it to a particular. Or deduction can be from general to less general, or at about the same generality. It just can't be any more general than where we are. Induction makes something more general. This does not. This uses generalizations. This creates them. So here's the form. So you get the basic idea. Particulars in a context, we get that. This we can apply to a particular. Much simpler, not so simple. This was figured out by some people, and then finally by Aristotle with the syllogism. He pretty much fully figured this out, got all the laws of it, figured out laws of logic from it, got some basic fundamentals. Even though he was great at induction and used induction to figure this out and to get some ideas about logic from induction, he didn't even figure out how induction worked. And it's only more recent that some people have done some good work on that. But it was necessary to look at this and to get some things with modern science after the 1500s. They got some Aristotle, some basic ideas from him, developed it, developed modern science, Galileo, William Harvey, Newton, others figured out modern science, and so we can look at that, and that helps us. That's something that Aristotle didn't have to figure out what this is. But deduction, induction, this can be certain. Some people say this is uncertain or only probable. It's a bunch of nonsense. If it is, then same thing here. You know, you can be certain about this or you can make mistakes. So then why can't this be? They don't call deduction uncertain too because they love it and they like want it to be all like fine and dandy and immutable. But we can go right or wrong in deductions. So can we here? That's irrelevant. What matters is figuring out when we're right. Same thing with this. Just because we can be wrong at something or mistaken, it doesn't mean it's invalid. It means people need to, you know, those people who are saying that need to grow up and quit acting like little 2-year-olds with a tantrum and just figure out when we're right and when we're not. Because we can't be right. To say induction is invalid is a generalization. All induction is invalid. Well, that's a generalization right there. And if all induction is invalid, then that's invalid. You know, you can't exclude your own things from a principle you're claiming. It's a fallacy of self-exclusion. If you're going to make a claim and you're going to do something, well, it sticks to you too, so deal with it. That's not true. That'd be a self-contradiction. Or all induction is only probable. If that were true, okay, well, then this is only probable, and you don't know. You don't know what you're talking about. Either your thinking is valid, or you don't know what you're talking about. And clearly that's a bunch of nonsense. So people like that should be just left alone. Ignore them. Don't waste time. The rest of us who are adults and humans and who want to figure out how the world works and do science and live, we know that some generalizations work. We need to figure out which one work and which don't. But like all redheads are hot-tempered, clearly invalid. Then racist stuff, all people of a certain race are evil or inferior, wrong. Those are generalizations that are wrong that we can use in contrast to something like this to help us see why these are right. Look at the mistakes. Look at how people do bad generalizations. Look at the good ones we make, and that'll help us see why these are good, just as people did with this. But deduction and induction, right there. All planets orbit the sun in elliptic orbits with the sun in one focus. Generalization. It's valid. All right triangles have sides in the relationship of a squared plus b squared equals c squared. Generalization. All ellipses can be considered as deformations of circles. You know, like you can get a flashlight, shine it on the side of a circle that's parallel to a table, and you get an ellipse. But that's a basic idea. So induction, deduction basics. This goes from particulars to a generalization in a context. This applies it, pretty simple. But again, a lot can go on here, like all lightning is electricity. You don't just see lightning and bam, it's electricity. There's a lot of context behind that in learning. Concept formation, other generalizations. People had to know what electricity was. They had to know math. They had to know to pay attention to the evidence of the senses. They had to know some stuff about science and about force. People had to have done experiments on static electricity already with the Leyden jars, as they're called. And then see that everything that electricity does is the same as what lightning does. You got the same kind of thing there. Not just an electric-like thing. It's not just like electricity, but it actually is. So a lot of stuff had to go on here to be able to process certain things, these little lightning things, and get that generalization. Or bond angles. All molecules of a certain type have a bond angle of 90 degrees or 102.5. Not obvious. To have certain things and to get that generalization is a massive context of atomic theory, physics, knowing about electromagnetics, light, crystals, chemical reactions, mathematics, all kinds of things. There's all kinds of things that are required to process this to get that generalization. So it's a massive context. Everything you know comes into play, whereas this is pretty simple. So there, induction versus deduction basics. Thank you.